Okay, let's move ahead to the liquid fuels. What we understood by liquid fuels. Okay, till now we have studied about solid fuels, about gaseous fuels. Now we will move towards the liquid fuels. So the liquid fuels are generally classified into two main types. Number one, primary fuels. For an example, crude oil. And number two, secondary fuels. So we can take an example of petrol, diesel, kerosene, etc. They all are considered as liquid fuels. Secondary liquid fuels. Now, it is very important for us to get fractional distillation of crude oil. Crude oil is the primary source, while the things or the products which we obtain are known as the secondary fuels, or I should say they are known as the artificial oils or artificial fuel. Okay, here let's take a look on the process of fractional distillation of a crude oil. So here the first step involves heating of a crude oil around 400 degrees Celsius in an iron retort produces hot vapor which is allowed to pass through fractionating column. Right? It is tall cylindrical tower containing a number of horizontal stainless trays at short distances and is provided with small chimney covered with loose caps so that it can get released. Now, as the vapors go up, they get cooled gradually and fractional condensation takes place. Higher boiling fractional condenses first, later the lower boiling fractions. Okay, this is the process with which we can get actually the crude oil distilled so that we get different kinds of products. Okay, now in the image you can see this is the fractional distillation column. Okay, the cylinder is there. In middle of that particular image you can see that is a cylinder which contains different stainless steel trays. From left side the crude oil, the steam are inserted. Firstly you can see the source of crude oil which gets inserted, then you can see the source of steam. Both get inserted inside the particular column, right? The fractionating column with bubble caps is there. Now, depending upon their boiling points, they will get separated, or even if it doesn't have boiling point, then it will get separated depending upon its boiling point. Okay, its melting point. Fine. So as you can see it here, first of all, we get heavy fuel oils, or from the upper side. If we move from the upper side, then flammable uncondensed gases are released from top of the column. At the second stage, we have petroleum ether. As we move ahead, we get petrol, then we have naphtha, then we have kerosene, afterwards we have diesel oils, then we have heavy fuel oils. And as we move to the bottom of that fractionating oil, which contains bitumen, right? The bitumen is a hard, black, coal tar substance, a very thick, semi-solid kind of substance, which can be removed from bottom of that particular fractionating column. Okay? Now, let's see that what is an octane number. You need to understand it here properly because octane number and cetane number plays a very important role. So, octane number is defined as the anti-knocking property of a petrol. It is known as anti-knocking property of a petrol. The knocking characteristic, basically the word which came into existence is the anti-knocking, right? So the word that came into our mind is knocking. So the knocking characteristic of a fuel can be easily expressed by octane number, right? The anti-knocking value of N-heptane is taken as 0 because N-heptane knocks very badly, right? It knocks, it continuously got shocked of that particular column and it knocks very badly, and because of that it is known as, or it has 0 value. Whereas the anti-knock value of isooctane is approximately taken as 100 because isooctane knocks very little. Right? Two different examples are there. And heptane. has a 0 value, while isooctane has a 100 value, right? In the image you can see this is the structure of TEL. Actually the octane number is the percentage of isooctane in a mixture of N-heptane in order to match the knocking characteristics of the fuel. Here TEL is added to reduce the knocking properties, okay? And the structure, as you can see, it is known as tetraethyl lead. So we have a lead in the middle and we have C2H5, 4 ethyl molecules present around that particular thing. This is best anti-knocking agent, okay? We can add that, or it is generally added. Now let's take on a look on advantages. So usually petrol with low octane number is not a good quality petrol. It is not considered as a good quality petrol. It often knocks generally, which produces, what do you understand by knocks? It produces noise due to improper combustion. Certainly a combustion occurs, and due to that improper combustion it gets continuously knocking, okay? As a result of knocking, petrol is wasted. The energy produced cannot be used in proper way and you will not get proper result, whatever you want from that particular petrol. So when tetraethyl lead, which is known as TEL, is added, it prevents knocking and it saves our money, it saves our energy. Usually 1 to 1.5 ml of TEL is added per liter of petrol. It is widely used in almost each and every kind of petrol. Now, if we talk about disadvantages, then for this purpose, like we have deposits of PBO are harmful for the engine because it contains TEL. So TEL contains lead and PBO is formed, and which is very harmful for any kind of engine. So PBO must be eliminated from the engine, okay? And for this purpose, a little amount of ethylene dibromide is added to petrol and it converts the harmful PBO to volatile PBBr2 and eliminated through exhaust. Presence of any sulfur compounds reduces the efficiency of TEL. So doesn't matter whether you add TEL or not. In this manner, this is the biggest disadvantage of it. Next is cetane number. Cetane number is defined as anti-knocking property of the diesel. Make sure this is the anti-knocking property of a diesel. The percentage of hexadecane, that is N-cetane, present in mixture of hexadecane and 2-methyl naphthalene, which has the same ignition characteristic of diesel fuel in taste. Generally, the diesel fuels with cetane number 70 to 80 is widely used and it is termed as cetane number. Diesel engine, because of the diesel engines work on the principle of compression and ignition, cetane or hexadecane is saturated hydrocarbon and its cetane number is arbitrarily fixed as 100. Now, a methyl naphthalene is an aromatic hydrocarbon and cetane number is arbitrarily fixed as 0. Okay, I am giving here an examples that how and which kind of compound actually shows you different types of values of cetane number.